So I forgot to record the live lesson, so I'm making a little video, just kind of walking through the notes. So this self-guided, basically it's page 1 and 2 of the notes. I suggest doing that before you watch this video. So if you're starting to play this video and you haven't done page 1 and 2, pause the video, go do page 1 and 2, because it's going to make a lot more sense when we're doing balancing equations. Okay, and remember, you're submitting the bottom part of page 2 to Schoology when you're done. Alrighty. So what we've been talking about in Unit 3 is chemical quantities. So we're basically measuring how much of a substance that we have. So we talked about moles, molecules, mass, things like that, and how we can measure, right, the amount of substance that we have using moles. We talked about how we can measure the amount of a gas using our ideal gas equation, right? We can measure variables, volume, pressure, temperature, and now we can calculate the amount of gas by throwing in that in variable, our moles, okay? So today and kind of the rest of the week, we're going to be looking at chemical equations and chemical reactions, and how if we measure the amount that we start with, we can actually predict how much we should be able to make in our chemical reaction. So in order to do that, we have to know how to balance equations, and we have to know just kind of the basic information about a chemical equation. Okay, so we know a chemical reaction is just basically rearranging the ways the atoms are grouped, and we can do that a few different ways. There's chemical reactions called synthesis reactions that are where maybe I have two things, A and B, and I've combined them together. I can also do the opposite, called decomposition reactions, where I can break down something into two or more parts. I also have, it's called replacement reactions, where see how A and B have kind of swapped places? So this is like a single replacement. I have one where like A and C can swap. Okay, so there's lots of different types of reactions that we can look at using a chemical equation. So we just need to kind of know the basic parts of that. So you probably remember if you took physical science or some signs that chemical reaction has occurred. So I know I can look for a color change, maybe some kind of solid forms. We call that a precipitate. Bubbles tells me a gas is produced. And then we also have this temperature change, where we can see, we can feel the heat, or maybe it gets colder, okay? Your parts of a chemical equation, this is kind of the beginning page of your notes that you practice identifying the reactants and products. This is really important when we're balancing chemical equations, because if we do not, when we're balancing, we kind of treat it like, separate sides of a bridge. So we have our reactant side, everything that's over here, and then we have our product side. Okay, so this is like our before the reaction and the after the reaction. Okay, so it's important not to get those terms confused. You may see some symbols of the physical states. Solid, liquid, and gas you probably are familiar with. AQ might be something new. This means aqueous. It just means it's dissolved in water. So a lot of times you'll see salts like NaCl. You might see acids like hydrochloric acid, HCl. Those are always dissolved in water. Water doesn't really play a part in the chemical reaction. That's why you don't see it in the equation. It's just there basically to provide a place for the reaction to occur. A lot of times salts need to be dissolved in order to react best. Some other symbols, make sure you know this triangle. That just means I'm adding heat to it. And then remember this arrow, that means yield. So like, what is my reaction yielding or producing? All right, so balancing equations. So I do want to just show you one kind of quick example from the simulation. So remember, I have my products and my reactant side. My products is my ammonia. My reactants is my nitrogen and hydrogen. One thing that to notice and to remember when you're balancing equations is when I'm changing my number in front of my element or molecule, my coefficient, that's changing the number of whole molecules. So notice how in order to get my hydrogen or my nitrogen, to match, I have to add another ammonia molecule. That didn't just add a nitrogen, it added the hydrogen as well. So I can't just say, oh, I'll just throw in another nitrogen over here, because that's not what actually happens in the chemical equation. Okay, so when I'm changing my coefficients, I'm changing entire number of molecules. So now that that's changed my hydrogens, right, I need to come over and I'm adding hydrogens over here. All this is saying is that in order for this reaction to occur, if I want to make ammonia, I have to have 1 molecule of nitrogen and 3 molecules of hydrogen, and it's actually going to make me 2 ammonia molecules. There is no way that I can just make 1 ammonia molecule. That's impossible. See how my doesn't equal sign? If I'm a hydrogen molecule short, my reaction is not going to take place. Okay? So it's important that you're that's all this balancing is saying. It's saying that in order to make 2 ammonia molecules, I have to have 1 nitrogen and 3 hydrogen. Okay? And if the equations are not balanced, then it's going to kind of mess up what we're doing later in the week, where we're trying to measure or predict how much we can produce of something. So back to the notes. We're going to be on the very last page of the notes where it says balancing equations notes, where it actually has equations out with blanks. Okay, that's where we're going to be at. And the first question on that page is, why do we balance equations? So this is why, right? We have the law of conservation of mass. Mass cannot be created or destroyed. So what it's saying is whatever number of carbon atoms I have on my left side, my reactants, I have to have that same number on my right side. Carbon atoms aren't just going to disappear. They're not going to just magically appear. I can't just, if you want to build a bicycle and you only have one wheel, can you make a bicycle? No, you can make a unicycle, but you cannot make a bicycle. So I can't just magically have things appear. Okay, so when I'm balancing the equation, that's all I'm doing. I'm just making each side equal each other. Okay, this number in front of my molecule, this is a coefficient. Okay, basically we treat it like a multiplier. I think that should be an I. A multiplier. So if you let's look at hydrogen here. Okay. So let's look at hydrogen. And here is my subscript. Okay. If I want to figure out how many total hydrogen atoms I have, I just do 4 times 2, and that's going to equal to 8. Okay. If I look over here, there's 3 carbon dioxide molecules. To figure out my carbon, right, it's just 3, because there's really an invisible 1. So 3 times 1 is just 3. Okay. And then one thing to note on my oxygen, I have multiple compounds with oxygen. I have oxygen here and I have oxygen here. Okay, so once I figure out how many's in each molecule, I'm adding it together to get my total. Okay, so just be careful. Sometimes you'll have multiple things. You want to make sure you're getting, this is your total for your entire product side. Okay, so you'll add them together. So let's do a few practice here. So you have your steps. You have a place to fill in your steps, some blanks. The first thing we're going to do is just count our atoms. So I'll show you how I do it. If you figure out a different way, that's fine. It doesn't really matter how you do it, as long as you can get yourself to the right answer. So here I have hydrogen and oxygen. I have 2 hydrogens and 2 oxygens. I get that from my subscripts down here. On this side, I only have 2 hydrogens and 1 oxygen. I draw a line down the middle so it can kind of keep me separated, and I'm not confusing the different sides of my equation. Okay. And I realize that I just wrote a 0. That should be a 2. I wrote oxygen equals oxygen. So there's 2 oxygen, 2 hydrogen. So now I need to look and say, is it balanced? Well, I can see that it's not. My oxygens are not equal. So now I'm going to balance. So the way that I do that is I actually ask myself, 1 times what is equal to 2? Well, 2. Okay, whatever number I put in the box, I put on the line. So now there's 2. Don't forget, because I put a 2 here, it's saying I have 2 whole water molecules. Okay, so I no longer have just 2 hydrogen, now I have 4. Okay, so I fixed my oxygens, but by doing that, now I have to go back and look at my hydrogen. So 2 times what equals 4, right? That would be a 2. So I'm going to put a 2 in front of my hydrogen because I'm talking about hydrogen. Okay, everything is balanced. Notice I don't have any number here in front of my oxygen. That's because there's an invisible 1. So if you feel comfortable, if you feel like you need to write the 1, just so you feel like you're done, that's fine. You do not have to. But don't go just putting any number in there or feeling like you need to do something else because there's no number there. There's not always going to be, you know, an additional number in front of the molecule or element. Okay, so let's do another one. So again, I'm going to just write out, I have 8 sulfurs and I have 2 oxygens. 1 sulfur, 2 oxygens. Okay, so I've counted, ask myself if it's balanced. No, it is not. My sulfur does not match. Okay, so what can I multiply 1 by to get 8? 8. 8 goes in the box, 8 goes in the line. Okay, one thing you can't forget to do is you can't forget to change your oxygens, right? Because this is saying I have 8 whole molecules of SO2. So 8 times 2 is 16. What can I multiply 2 by to get 16? 8. Notice I'm talking about oxygen. So my 8's going to go in front of oxygen. What goes in the box goes on the line. Everything's equal. I don't need a number here because there's an invisible 1. So I can write my invisible 1 down if I need to. I'm going to continue. Feel free if you need to pause, you know, and catch up. That's fine. All right, so we have, I just fixed mine on my screen, so it's all in one line. We have a little hint, so I suggest in your notes you make a little box with like some hints. We always want to save hydrogen and oxygen for last when we're balancing. Okay, so always save those for last. A lot of times they do crazy things, and if you save it for last, it kind of all fixes itself, and it just saves you a big headache. Okay, so I'm going to go through and count. I suggest you do this as well. Maybe try to do it without looking at mine and see if we get the same thing. Notice how I write out my elements. I do them in the same order on each side. That way that I'm like across from each other. Even though it's not the order that they're listed in the equation, it's just easier for me to see what I'm looking at. I'm not trying to look at multiple lines and get confused. Okay, so I want to save oxygen for last. Okay, so I'm going to come down and look at sulfur because it's not balanced. So S times what equals 5? 5. What goes in the box goes on the line. Notice I put it in front of the S because I'm talking about S. Now I can't forget to recount. This is where most people mess up, is you forget to recount. So now I have 5 calciums. Okay, again, I'm saving oxygen, so let's look at calcium. 1 times what equals 5? 5. So I'm going to put what goes in the box goes on the line. Don't forget to recount your oxygens. Now I have 5 oxygens because remember, it's 5 of those whole things. And then look, my oxygen fixed itself. I didn't even have to do anything. And then my V is also equal vanadium. Don't forget, there's an invisible 1 in those spots. You can write the 1. Don't go changing your numbers down here below thinking you need to get a number in those blanks. There's already an invisible 1. Okay. All right, here's another hint. Okay, we're always going to do our polyatomics first. Remember, polyatomics are things that ions, right, that act, they're molecules, they're bonded, together, but they act like one thing. Okay, so I have a polyatomic carbonate, CO3, in this equation. Okay, I'm going to treat it like one thing, and this is what I mean by that. So I'm going to go through and count. So I have 1 silver, 1 iodine, 2 irons, and then here's my carbonate. I'm going to write down CO3. I'm not going to write down carbon and oxygen. Okay, you're going to give yourself a headache. My little subscript down there tells me there's 3 of them. Now I'm going to go over here, 2 silver, 3 iodine, 1 iron. Notice I don't have any kind of additional subscript. I just have the CO3. That 3 belongs in carbonate. There's nothing down here, so I just have 1. Invisible 1. The second part of our hint is we're going to balance our polyatomics first. So that means I'm going to start with my carbonate. So 1 times what equals 3? 3, what goes in the box goes on the line. Not only is there 3 carbonates, now I have 3 extra of the whole thing, right? So 3 times 2 is 6 silvers. So now let me go look over here. I'm just going to kind of start at the top. It doesn't really matter where you go after this because we don't have any hydrogens and oxygens. So I'm just starting at the top since I just did silver. 1 times what equals 6? 6. What goes in the box goes on the line. Notice I put it in front of silver because I'm talking about silver. Don't forget to recount your iodine because there's 6 of this whole thing. So now 3 times what equals 6? 2. 2 goes in the blank in front of iodine. Don't forget to recount your iron. Now there's 2. And then look, that balances itself for you. So everything is equal. Okay, so now I can just do my invisible 1 and then I'm done. Again, pause there if you need to. All right, last one. I want to try this one. There's multiple ways you can do this, balancing equations. You can do it how I've written everything out and do the box. I call it the box method, where you do times what is going to give me what I need, and then whatever goes in the box goes on the line. That is very simple to some people. Some people get that super quick, and it's great. You can fly through these equations. Sometimes it seems a little too jumbled and a little too much for some people's brains, and that's totally fine. I'm going to show you how you can kind of do it in your head. The one thing, though, is that you just kind of have to double check yourself to make sure that you actually balanced every element and you didn't forget any. So we do have a polyatomic, NO3. Okay, so remember that's like that one there and over here. Okay, so I'm just going to kind of go through and look at things individually and then count them on both sides. So I'm always going to start with my polyatomic, right? That's my hint. I do have some additional oxygens. I'm going to save those for last. I don't count those with my oxygen and my polyatomic, right? It's NO3, that's one thing. So I have 2 over here on my product side, 2, and then I only have 1 here. So I know that I need to put a 2 on the line. That's going to give me 2 of those things, right? Now let's just now I'm just going to kind of work down my line, okay, and make sure I double check everything. So now I'm going to look at sodium. Let me change my color so you can see. I have 2 sodiums here, 2 sodiums here, so I'm good to go. I don't have to do anything with sodium. Let's look at lead. I have 1 lead, 1 lead, Pb. I don't need to do anything to lead. Okay, now let's look at oxygen. 1 oxygen, 1 oxygen. I don't need to do anything with any of that. Okay, so I'm done. Everything matches up. The only thing I actually had to change was my nitrates, my NO3. So remember, these are all just a 1 because they're invisible. Okay, so that way is a little bit faster just because you're not having to write things down below. You have to be careful, though, that you actually check every element in your equation. Okay, sometimes it can be very easy to skip something or forget to go back to something. If you change, if we had to change something over here to like a 2, If you don't forget to go back and check, at the end and make sure that everything is actually balanced, you could miss something. Okay, but that is another way that you can do it. So that's the last of the notes. You do have a quizzes posted. I highly suggest playing the quizzes at least one time. That will give you kind of an idea of how you are with balancing equations. There's 5 minutes for the questions, so you have plenty of time to write it out, to count and everything, to check your answer. Don't feel like you have to rush. There's also a few other little questions, just general questions about chemical reactions, like what are reactants, what are products, okay, just to kind of refresh your memory as you're going through. But this will at least give you an idea of where you sit, kind of how you feel. Maybe you find out, oh, I'm not good at this, I need some extra practice, or maybe I need Ms. Phillips to show me a few more examples. If that's the case, message me. I do have free time tomorrow. So if I need to do like a little small group or something, or individually get with you to kind of go over things, or look at something else, we can set that up. So good luck. Don't forget to submit your picture of your name from page 2, and then I suggest playing the quizzes, at least one time. If you do great, get most of them right, then you're good to go. All right.